A video was produced in 1992 called The Greening of Planet Earth. It explored the positive aspects of increasing amounts of carbon dioxide in the atmosphere. It examined how enriched levels of CO2 stimulate faster growth in trees and plants, improve water use efficiency in all growing things, and increase the yields of almost every important food crop globally. The video also convincingly countered scarce stories in the media about the frightening ramifications of global warming. And today, the greening of planet Earth remains a very positive vision of life in our world.
Yet there are still TV news reports speculating about the spread of tropical diseases and about sea levels rising 2 feet or more. Still newspaper stories speculating about vanishing wildlife and about crop-devastating droughts. And still magazine articles speculating about melting glaciers, summer heat waves becoming more intense, and hurricanes and storms increasing in severity. These reports are pretty powerful and pretty scary, but are they true?
Are all these terrible things going to happen? Are rising levels of carbon dioxide causing apocalyptic global warming? And does recent scientific evidence contradict anything that was said in the greening of planet Earth? There's no question that the level of carbon dioxide in the atmosphere is increasing, from about 270 parts per million before 1800 to about 365 now, to an estimated doubling to 720 or more within the next 100 years. But is this leading to apocalyptic global warming?
Contemporary news reports would have us believe it is, and they're still speculating. Global warming is no longer in doubt. Left unchecked, global warming would lead to environmental holocaust. Climate Panel is confident of man's link to warming.
Since temperature measurements indicate that there has been a slight warming over the last century, what can we learn about it from the Earth's climate history?
Over the last 100 years, the instrument records say that the Earth has warmed about 0.5 degrees centigrade. But most of that warming occurred early in this century, before most of the carbon dioxide from human activities were put in the air. So that early 20th century warming had to be natural. What is the cause of that warming? Now, the sun changes in its energy output every 11 years with its sunspot cycle. Sunspots are these areas of intense magnetic field, and they come and go every 11 years. And we have records of that going back 400 years, since the time of Galileo. And the ups and downs of the sun's magnetism match up very well with these changes in the climate of the Earth. So we estimate that most of the changes of the last several hundred years, and in fact some have estimated the last 10,000 years, can be caused by these fluctuations in the sun's energy output.
The climate is naturally very variable. It has changed quite a bit over time. 50 million years ago, it was about 20 degrees warmer than it is today. It's gotten gradually colder over this period of time, but with sharp ups and downs. Since the last ice age, there have been 2 warm periods dubbed by climate historians the climatic optimum and the little climatic optimum. The climatic optimum was 4,000 to 7,000 years ago. It was about as warm as they're predicting is going to occur at the end of the next century. And it was a great period for human beings, for plants and animals. The second, the little climatic optimum, was 1,300 to 1,000 years ago, and again
led to tremendous advances in city building, in exploration, in cathedral building, in university building, because people were not victims to the cold climate so much. So they could go out and grow crops, they were healthier, they were longer lived, and all this because the climate was a bit warmer.
A slightly warmer world and an enriched carbon dioxide world will mean plant growth is more vigorous. The bottom of the food chain is plants. All animals eat plants or eat animals that eat plants, including us.
The question everyone should ask is not, is the Earth warming? But how is this warming being felt across the planet? Where is it warming? When and by how much? It turns out that most of the warming is occurring in the high latitudes in the winter and across the planet and at night.
For whatever reason, right now, it becomes quite newsworthy to go out and tell people that we are about to have apocalyptic climate changes. And the second you make that pronouncement, it's easy to go around the world and find examples to support your viewpoint. But it would have always been easy. There would be no time in Earth history when you would not have been able to go around the world and find damaging hurricanes and tornadoes and whatever. They are not linked to the buildup of greenhouse gases.
The evidence that increasing carbon dioxide in the atmosphere is going to cause a disaster is somewhere between slim and none. However, the evidence that it's doing a good thing by lengthening the growing season and making plants grow better is somewhere between large and overwhelming.
You know, there's more in the research about this little climatic optimum period. The Anasazi Indian civilization in the American Southwest reached its peak because the people were able to farm twice the amount of land as before. It was warm enough in England to grow grapes and support a thriving wine industry. And since alpine mountain passes were no longer blocked by snow, trade routes opened between Italy and Germany.
These warmer periods in history become even more interesting when you realize that they occurred when the level of carbon dioxide in the air was far lower than it is today. This makes it pretty difficult to make any connection between rising CO2 and the even slight temperature increase we've observed during the last 100 years. So, if sunspots account for the Earth's small amount of warming, if we're warming mainly the coldest parts of the planet in the winter and at night, and if warmer is better than colder, then why all this controversy?
Because of computers and computer simulations called general circulation models. So what are general circulation models? What do they try to do? And how hard or easy is it to make a realistic one?
General circulation models, or GCMs as we refer to them, are trying to simulate the climate of the Earth at the surface as well as through the upper atmosphere. The climate includes not only temperature and precipitation and cloud cover, but also the atmospheric winds, changes or the movement of these systems over time from one month to another, evaporation from the oceans and from the land, precipitation onto the surface, global ice, sea cover, all the aspects of the Earth, of the planet, that are related to the atmosphere and to the oceans.
It's very difficult to create a realistic computer model because the atmosphere and the surface of the Earth and the oceans and vegetation systems are all so very complex. And the ways that all of these components of the system interact are so complex. They interact in nonlinear ways, which we really can't predict. One thing changes, which changes something else, which changes something else. There's this cascade of processes.
People have to understand that the entire global climate change hysteria is driven by computer models. It is not driven by reality. Reality is not warming up like those models said it would.
The models say that there should have been warming of about 1 degree centigrade. There's only been half a degree, and it occurred before most of the greenhouse gases were put in the atmosphere. In the last 20 years, there should have been warming of maybe 3/10 or even half a degree centigrade, according to the computer simulations. And the very precise satellite records tell us the Earth hasn't warmed at all in response to this greenhouse gas increase.
Well, there are 3 different systems for monitoring global temperatures. The surface temperature data set from thermometers, a satellite data set from Earth orbiting satellites, and then weather balloon instruments, which are, of course, launched from the surface. Well, we only have all 3 of those data sets for the last 20 years. That is, since satellites were launched in the 1970s. But what they tell us is that the surface temperature measurements suggest a warming.
In terms of the land-based record, which does show some warming, there are a number of problems that need to be considered when we're looking at those records. One is that at the beginning of the period of records that where we were taking temperature observations, many of these cities were located in shallow sloping valleys where cold air tend to pool.
Then there's the problem of having a thermometer over land in a good location where a modern city grows up. Now, modern cities have concrete buildings that generate heat, cars driving by. All that creates an artificial heat that elevates the temperature but doesn't really reflect a true climate measurement.
The result is that the temperature record at the surface is a contaminated record, and urbanization needs to be factored out of that if we're going to get any kind of accurate representation of how surface temperatures have changed over the last 100 years.
What's surprising, though, is the satellite system that was specifically designed to precisely measure planetary temperature shows no warming whatsoever. We have balloons that go up through the atmosphere twice each day from locations around the world, and they're in near perfect agreement with the satellite record. They see no warming at all.
So we have a situation where the surface thermometers show warming, the satellites and the weather balloons do not. And climate models tell us that all of those systems should be seeing warming.
The models themselves look pretty good at first glance, but actually they're not well connected when it comes to the ocean and the atmosphere. There are problems with the clouds and the rain and the surface energy balance, and there are problems with the ice caps, and there are problems with energy fluxes in low latitudes. And I have a friend who says they're like sausage. You really like them until you know what's in them.
There's been a big change in the amount of forecasted global warming since 1990. In 1990, the official prediction of global warming was about 3.3 degrees Celsius by the end of the next century. More recently, in 1992, that was revised downward to 2.8 degrees warming. And in 1996, the warming estimate has been further reduced to 2 degrees.
In virtually every case, as the models have improved, and as we have improved our representation of changes in atmospheric chemistry, the predicted temperature rise into the future gets smaller and smaller.
The most recent scientific evidence is overwhelming that the forecasts of global warming are going to have to be reduced even further in the future. At what point does this thing become an issue that is simply a non-problem, even to those that are concerned about it?
I also found something interesting in the research about computers and general circulation models. Here, in order for a computer to run a complete circulation model, one that takes into account all the known aspects of our climate system, scientists would need 10 to the 36th power more computing capacity. That's 10 followed by 36 zeros.
Well, so far we've observed a very dynamic climate with numerous up and down fluctuations in temperature, and computer simulations that aren't as trustworthy as anyone would like. So why don't we take a closer look at this carbon dioxide we keep hearing about?
It seems that every time they mention carbon dioxide on television, there are unpleasant video clips of factory smokestacks and car tailpipes. Is what they're showing CO2? Is carbon dioxide a pollutant?
Carbon dioxide is not a pollutant. Carbon dioxide is a nutrient, a very important nutrient, perhaps the most important.
I mean, CO2 has been part of the planetary atmosphere since the first day this Earth evolved. And the plants and virtually everything we see evolved in a period of time when the CO2 level was very much higher than it is today. CO2 is something the plants love. They take up CO2, they use it, they give out oxygen. We take the oxygen and give out CO2. So it's hardly a pollutant at all. It's quite a naturally occurring gas that appears in our atmosphere, and it's very important to sustaining life on this Earth.
In terms of the broad geological perspective, the carbon dioxide concentration of the atmosphere right now is low. Almost all the plants that we live with and depend upon for food evolved in an atmosphere when the CO2 was higher in the atmosphere, much higher than it is today, and higher than we could possibly get it even if we tried.
Well, as a matter of fact, there were times when life flourished on Earth. The time when CO2 levels were something like 10 times current levels was when the dinosaurs were running around, and that was when the plant growth was so vigorous that they created all the oil and gas that we now use. It was a very fertile period of time for the Earth.
Yeah, some scientists believe that 9,000 or so years ago, agriculture sprung up all over the world. We saw people domesticate plants in Southeast Asia and Asia and South America and Europe and North America all at about the same time. And it also corresponded when the carbon dioxide levels had increased from about 200 parts per million to about 250 parts per million. And it gave agricultural plants a competitive advantage over weeds. It may be that carbon dioxide is the reason we domesticated plants.
When we've looked at the literature on experiments that have been done with increasing levels of carbon dioxide, what we basically find is that most plants respond the same way. More carbon dioxide gives us more biomass. So if we look at a forest a rangeland, a marsh, a wetland, or an agricultural field, what's really happening with more CO2 is that you have more plant material produced.
Increased CO2 worldwide, with few exceptions, means plants grow better, period.
We can see plants growing better and also see the results of CO2 as a plant nutrient in the Netherlands, where they grow food crops and flowers in enriched levels of CO2. And they do it in glass houses, what we call greenhouses.
We're about to visit PBG, in English, the Research Station for Floriculture and Glasshouse Vegetables. It's a government-sponsored facility in Naaldwijk, just outside of Amsterdam.
We grow vegetables at 2 till 4 times the outside carbon dioxide level. That means between 700 and 1400 parts per million. We are growing all the vegetables that commercial growers are growing, but the main products are cucumber, tomato, pepper, eggplants, squash, lettuce and radish. The results of growing at elevated CO2 levels are a more rapid growth, earlier maturity, larger fruit size, greater weight and a greater total yield of about 25%. As a standard, commercial growers are using CO2 enrichment in the glass houses, and the results they find are about the same results we find in our experiments. Throughout Europe and also throughout the world, commercial growers with modern greenhouses are using elevated carbon dioxide levels, the same as in the Netherlands. We go up to about 1500 parts per million. That has no negative effect on human health. To get negative effects on human health, you have to go much higher. That's higher than 5,000 and 10,000 parts per million, at least. Looking at rising levels of CO2 from the viewpoint of the plant, that's no problem at all. We will have a higher production.
Talking about higher production, there are about 25,000 acres of commercial greenhouses in the Netherlands, growing vegetables, flowers, and bulbs worth some $7.5 billion a year. And greenhouse agriculture is expanding all over the world, from Spain, Italy, Turkey, and Greece to Japan, Taiwan, China, and Korea.
Since only about 25 food crops stand between humans worldwide and starvation, let's take a closer look at carbon dioxide and its effect on food production. Are rising levels of CO2 a frightening thought?
Rising levels of atmospheric carbon dioxide do not frighten farmers. They do not frighten foresters. Forestry output has increased, agricultural output has increased. And this applies to all the food crops, and food is the most important renewable resource we have.
Probably the single most important food crop globally is rice. And from my experience working with tropical rice in the Philippines, certainly CO2 is able to increase yields of rice, most of the traditional semi-dwarf varieties of rice that are utilized. And so hopefully that will increase rice yields as CO2 increases in the atmosphere.
We have found that increasing the CO2 level from the current level to 2 times what we have today would basically increase plant yields. We've worked with corn, we've worked with soybeans, and we've worked with wheat. For corn, our yield increase is about 17 to 18%. For soybeans, it would be more, about 25%. And for the wheat, it would be probably between about 20 and 25%.
I look at the literature fairly regularly on this, and it seems overwhelming that plants throughout the world, agricultural plants, do very well when the carbon dioxide is increased. We see soybeans in Iowa being reported upon that have a much higher yield for higher CO2. We see strawberries in China and grapes in Italy. We see winter wheat in Europe. And you can go around the world and you see evidence that increased CO2 yields more productivity for our most important agricultural crops.
It's been estimated that the rising level of atmospheric CO2 have enhanced global food production by ranging from 8 to 12%. Now this is a universally free subsidy that is increasing daily, that is available to all and to the entire earth and to all food crops and all forest crops and all range crops.
Increased carbon dioxide may change where plants grow, especially in terms of being able to grow in drier places. so that the distribution of plants may change as carbon dioxide goes up.
Doubling of CO2 would cause not just an effect on individual plants, but also a redistribution of the plants around the world. And there are people who argue that dryland areas, like this desert we're sitting in right now, could be greening up a bit due to the increase in CO2. And in some dryland areas where it's rather marginal in terms of people getting by, this increase in plant cover could ultimately yield an increase in grazing and more cattle, and maybe an increase in standard of living in some of these countries.
I think we should monitor the increases in carbon dioxide. We should look and see how plants are growing, how the ecology is changing, and then we should adapt. That's what people do best. We are an adaptable species. Plants are adaptable, and we should work with the Earth system as it changes.
Well, scientific research shows that enriched levels of CO2 have a positive effect on just about every important food crop around the world.
And in addition to what was just mentioned, there are numerous additional experiments that confirm it. In Switzerland, peanuts, beans, and peas. In England, wheat and strawberries. In Italy, soybeans. In Canada, tomatoes and peppers. And in Denmark, barley. Not to mention cotton in Mississippi, pasture land in New Zealand, and clover in Germany. In addition, a doubling of CO2 may even cause a greening of many lands worldwide now considered to be marginal.
Enriched levels of CO2 mean faster plant growth, increased agricultural yields, and something else of great importance.
Increased levels of CO2 have another consequence. In particular, they can improve the water use efficiency of plants.
And that is the amount of water that's used by plants to produce the same amount of growth actually decreases with increased CO2.
When we have the elevated CO2, the higher atmospheric CO2 level makes it easier for CO2 to go into the plants, so the pores, called stomates, don't have to open as widely. When the pores aren't open as widely, then it's more difficult for water to come out.
So there's actually less water loss per unit of carbon that's being taken up into the plant. And as a result of that, water use efficiency goes up.
So a higher water use efficiency means we're using CO2 more efficiently in terms of the water requirements for the crop.
This will change some of the ecosystems. It may allow some plants to grow in areas that now would be considered marginal for the growth of those plants. So we'd have more biomass production, plants in a little bit different area, and we may actually be able to farm some of the areas that would now be considered desert.
And this is important because in the world we're in today, water is going to become probably the most limiting natural resource as far as food production is concerned and as far as the biological productivity of the earth is concerned. There's a limited amount of fresh water in terms of quantity. There's a limited amount of fresh water in terms of quality.
According to the World Bank, 40% of the Earth's population could be living in countries with insufficient water supplies by the year 2025. So improved water use efficiency can be critical.
Enriched levels of CO2 also have a positive effect on trees. In fact, trees have already been positively affected. In 1992, the Forest Research Institute of Finland reported a 25% increase in forest growth between the early 1970s and the late 80s for all the countries of Europe. And this included Germany's Black Forest, once thought to be dying out completely. And other studies indicate that by doubling the CO2 content of the atmosphere, the growth rate for many trees could double as well.
It's estimated that 95% of all fruit trees, 95% of all nut trees, and 95% of all forest species could expect to have dramatic positive responses to enriched levels of CO2. And this includes loblolly pine in Georgia and Scots pine in Belgium.
One of the major ways which we use to study effects of elevated CO2 is open-top chambers. Within these open-top chambers, we enrich the atmosphere with CO2 and compare the growth of the trees within the chambers with trees in similar chambers without additional CO2, as well as with trees grown outside the chambers.
For a number of years, I've run an experiment in elevated CO2 in this loblolly pine plantation, where we've enclosed portions of the canopies above us in enriched levels of CO2, 50% higher than the current ambient and 100% higher than the current ambient.
With increasing levels of CO2, most trees increase their growth and their biomass productivity. This could be both above ground and below ground. In our experiments with pine and poplar, this has been very pronouncedly being shown, as well as in many other studies in the United States and in Europe.
I think most scientists are finding that elevated CO2 is enhancing productivity in forests. The degree of enhancement is dependent on other resources on the site. If sites have high fertility, the enhancement is large and long-lasting.
Nitrogen is one of the most essential nutrients for the plants, which the plants take up from the soil. Under increasing levels of CO2, the nitrogen use efficiency, which means the carbon taken up per unit of nitrogen taken up, is increasing, is improved.
The timber industry in Georgia alone is a $14 billion industry. The increase in CO2 in forests in Georgia and the southeast should increase forest productivity and should increase the amount of fiber available for the industry for paper and wood products.
Within Europe, we're working together in a research network with 15 different labs and research universities in different countries in the European community. We all do similar studies with elevated CO2 on a number of different tree species. Most of the results from this collaborative effort have shown that all species improve their growth and productivity. However, the magnitude of the response differs depending on the species, the site and water conditions.
Water use efficiency is enhanced under elevated CO2 conditions because the trees are growing more, but they're using about the same amount of water. Water use efficiency was actually increased 2 to 3 times in trees that were growing under elevated CO2 conditions.
Forests cover about 1/3 of the world's surface, so they play a major role in the carbon balance of the globe. Under increasing levels of CO2, we have seen that some of the forests improve their carbon uptake. Some of the carbon which we release from fossil fuel burning is not retrieved in the atmosphere nor in the oceans, and might have been stored in the forests on the different continents in the world.
The reality here is that it's very difficult to find any relationship between carbon dioxide and dramatic global warming. What we know for sure is that the climate change we can reliably expect is both modest and benign.
Only unreliable computer simulations predict apocalyptic global warming. Provable observed reality tells a very different story about a small amount of beneficial nighttime winter warming in the coldest air masses. Carbon dioxide is a plant nutrient that causes faster growth, increased yields, and improved water use efficiency. And this translates into more vigorous tree growth worldwide, the ability to grow more food for more people, and the capacity to grow it on what are now marginal lands.
When we strip away all the scare headlines and oversimplifications, a very different picture emerges. A picture of humanity and nature growing together, adapting to changes in the environment as we always have. A picture of people enjoying the benefits that enriched levels of carbon dioxide bring to all growing things. And a picture of the ongoing industrial evolution of humankind as the greening of planet Earth continues.